Okay, so in this video we're going to convert from rectangular equations, which are equations that we've been used to, things with x's and y's, into polar equations, which are things with r's and thetas only. No x's, no y's. And we're going to use these equations here in the blue box to help us with that. Okay, so we have x squared plus y squared. So which of those can get us an r and or a theta? Well, right here, x squared plus y squared is r squared. So this is r squared is 14. So r is the square root of 14. Okay, so that is just a circle with a radius of square root of 14. And if you look back at originally, well, think back to conics, circles. This is the circle with a radius of square root of 14. Okay, so r just means it's all angles that have a radius, meaning the square root of 14, right? A little less than 4 circles out, but all around the circle because it's all angles. Okay, so this has no x's and y's. It is a polar equation, so we are done. Okay, so for number 2, we have x equals 3. Okay, so if you think about algebra 1, x equals 3 is just a vertical line, okay, going through the x-axis at 3. Well, x is r cosine theta. So x, I'm going to replace x with r cosine theta, and that equals 3. So I just replaced the left-hand side. Okay, so now we no longer have x's, which is rectangular, and we have an r and a theta, which is polar. And typically for polar equations, it's r equals something, if we're going to have an r in it. So I'm going to divide both sides by cosine. So r is 3 over cosine of theta, and 1 over cosine is the same thing as secant of theta. So this has r's and thetas in it, so that's a polar equation. C, very similar problem, but it has a y, and y equals r sine theta. So I'm going to replace y with r sine theta equals 2, and again, divide both sides by sine of theta. And the reciprocal of sine of theta is cosecant of theta. So that is my polar equation. Next I have the line y equals x. And if you think about it, the line y equals x is the line that goes through the origin that kind of splits it in half. Okay, now think of polar graph paper. What angle is kind of splits the quadrant in half? Well, that's the same thing as the pi over 4 angle, where over here it's 5 pi over 4 angle. It's that angle. So this line is the same thing as the angle. If you can think about it other ways, y is equivalent to r sine theta, x is r cosine theta, just using the top two conversions over here. So where are those two equal? Where in the unit circle is r sine theta equal to r cosine theta? We'll divide both sides by r, and you get, oops, the r goes away, and we're left with sine of theta is cosine of theta. So what angle is sine of theta equal to cosine of theta? Well, over here at pi over 4 and over here at 5 pi over 4. So you actually have two answers. So the answer I'm going to choose is pi over 4. Okay, so it's anywhere on the line pi over 4, which is also anywhere on the line 5 pi over 4. So that's also true. Okay, because they have the same x and y coordinates. Okay, E, I see an x squared plus y squared again. So I'm just going to replace x squared plus y squared with what it equals. X squared plus y squared equals r squared minus 8y. Well, y equals r sine theta. And that equals 0. Okay, so I'm just going to do some algebra. So I'm going to bring my 8r sine theta to the other side. I'm going to divide both sides by r. And I get r equals 8 sine theta. And here I have a polar equation, just r's and thetas, no x's and y's. Okay, So on the next problem, example number 5, we're going to go backwards. We're going to start off with polars, which is r's and thetas, and I want to get to rectangular, which is x and y's. So polar, trigonometry stuff, rectangular, algebra stuff. Okay, so we're going to do the exact same thing. R equals 2 secant theta. So what I want to look for is, do I have an r cosine theta somewhere so I can get an x? Well, if I divide both sides by secant, or if I remember that secant is the same thing as cosine, 1 over cosine, so just replacing secant with 1 over cosine. So now if I multiply both sides by cosine of theta, they'll cancel on the right-hand side, and now I have an r times cosine theta on the left-hand side, just changing the direction I wrote them, equals 2. Okay, my r cosine theta equals 2. R cosine theta, using my formulas, equals x. So x equals 2. And that is a rectangular equation. No r's and thetas, just x's. Okay. For b, I have r equals 3. Well, a nice equation I have is r squared equals x squared plus y squared. So if I squared both sides, so r squared equals 3 squared, or r squared equals 9. So just square both sides of your equation. R squared is x squared plus y squared, because remember, our goal is to get rid of r's and thetas and introduce x's and y's. So r squared is x squared plus y squared, right? I'm just replacing r squared, right, with x squared plus y squared. So this is an equation with x's and y's, no r's and thetas. X squared plus y squared equals 9. That's a circle with radius 3, back from the conic section. R equals 3. Well, that means, if you think of your polar graph paper, it's your third circle out, and there's no restriction on your angle theta, right? So we don't have to go just to some point. It's all the angles theta on the third circle out. So it's a circle of radius 3. Same idea, just different coordinate system. So here we have theta equals pi over 6. That's a line, right? So if you're looking at your polar graph paper again, and you had your axes, pi over 6 is this line here. So pi over 6 would be this whole line. It doesn't say any restrictions about how many circles out, it's just that line. So if you think about it, what line is that? If you get rid of your circles, okay, then you're in algebra class. You get rid of the polar graph paper. What's the equation of that line? Well, if you were one circle out, that would be the unit circle, and this angle is pi over 6. The coordinates on the unit circle for pi over 6, you went over root 3 over 2, and you went up 1/2. So if you start at the origin, I went up 1/2 and over root 3 over 2. So you can just kind of do a slope thing. You can also just look at your equations. Tangent of theta is y over x. So tangent of pi over 6 is y over x. Well, I know my y. So tangent of pi over 6, my y over x. My y is 1/2. My x is root 3 over 2. Well, those numbers were just rise over run. It's the slope. Okay, so tangent, using trigonometry on this side, tangent is y over x, 1/2 over root 3 over 2. That equals y over x. I did tangent, unit circle to get that. Introduce my y over x, which is my rectangular coordinate system. Multiply both sides by x, so that they cancel. And you get y equals 1/2 over root 3 over 2 x. So simplify that fraction. It's 1/2 times the reciprocal, 2 over root 3 x. So that says y is 1 over root 3x. And then just rationalize y equals root 3 over 3x. So now we have a polar equation, or sorry, a rectangular equation, just y's and x's, no r's and thetas. Okay, and we are done with that.